Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. We've derived now the OVB formula for the bias, which was beta 2 times covariance of x and z divided by the variance of x. So the key question now is the bias positive or negative? In practice, you rarely know the exact size of the bias, but you can almost always work out the sign, and that's often enough to know whether what you estimate is too high or too low. It's also pretty common in exams to have questions that ask you to indicate the direction of the bias and to make a comment on whether you have overestimated or underestimated your model. So this video should help you to get through those kind of questions. Now, let's simplify the formula a little bit in here. The variance of x, as you know, is always positive. The variance of something is always positive, which means that the sign overall of the bias will depend only on two things. It will depend on what the sign of beta 1 is, and it also what the sign of the covariance between x and z is. So the combination, basically, of these two signs is all you need in order to be able to get an idea of what the sign of the bias is. For the beta 2 was coming from the true model. The true model from the previous video, we said it would be y equals to beta 0 plus beta 1x plus beta 2z plus an error term. So the beta 2 is coming from the true model. So that means all we need to do is run this regression and see what the sign of this beta 2 is, or by going through a correlation between z and y directly get an idea of or a sense of how do I expect this in relation to be. The next bit is the covariance between x and z. So where exactly is this now going to come from? Because we need the sign of the covariance between x and z. And that is also something that you can get, because ultimately you can run a regression of x on z to see exactly the sign of that, okay? Now, overall, knowing that we have these two elements simply to really get the sign of the bias means that we can come up with a small table like this one, where we've got the sign of beta 2 and the sign of the covariance xz, which tells us ultimately the sign of the bias. Because if beta 2 is positive and the covariance is positive, this bias is ultimately positive. If the beta 2 is positive while the covariance is negative, or the opposite, then the bias sign is negative. And then if both of them are negative, the bias is again positive overall. Okay, so we've just simply used the multiplicative element of this bias formula to simply come up with the overall sign of our bias. Now, let's look into an example. Let's say that we've got education and ability. Okay. Let's say we've got education and ability, and we omit ability from the wage. So that means that if we have y equals to beta 0 plus beta 1 education plus beta 2 ability plus an error term, the beta 2 is clearly bigger than 0 because ability increases income, okay? Higher ability would means higher income, okay? Now, what about education and ability? Are they positively or negatively correlation? Well, the covariance between ability and education, we'd expect to be positive because they are both, like the higher the ability, the higher the education that you can pursue later on. So that means that overall, since both are positive, then the bias is positive. So what does that mean for us to have a positive bias? It would mean that if you exclude ability, then the beta of education will be overestimated as as a result of these positive bias, okay? Because education would have included the positive effect that ability would have had on income as part of its beta 1, so it would have shown as something bigger than it actually is, okay? What about the case of a negative bias? So let's look at example 2. In this case, let's assume that what we are omitting is actually job tenure. Okay, so does tenure increase wages? Yes, so beta 2 for tenure would have been positive. However, the correlation, let's say hours worked, covariance between hours worked and job tenure would have been negative because newer employees usually are the ones that work longer hours. So that would mean that out of a positive beta 2 and a negative covariance, then we would have had a negative bias, which means that in the case where we exclude the effect of job tenure, then we would have underestimated the effect that hours worked have on wages, because the effect of job tenure would have been included in it, and instead of giving us the pure effect of hours work, would have included that negative effect that job tenure would have had on hours worked per se, okay? So anything that gives us a positive bias basically means that we are overestimating, and anything that gives us negative bias means that we are underestimating things, okay? Now, at the same time, you can look at this also as like the omitted variable bias moving in the same direction as x and as x, which means that you are pushing the value like upwards. So it makes x look more powerful than it really is. So sometimes that's why you'll also call it as upward bias, while the negative bias, you'll call it also as downward bias, okay? But keep in mind, overall, this is our result because the omitted variable bias contaminates x in a direction determined by their correlation. Very often in exams, you will be asked, is the estimated coefficient biased upward or downward? And the answer is going to be either like you giving a negative or a negative bias, but nevertheless, it's always going to go through the process of you identifying the omitted variable bias. So let's actually write those steps in here. So identify the omitted variable bias, determine the sign of beta 2, determine the sign of the covariance between x and z, and then ultimately multiply the two signs in order to get the final answer. Okay, so you can answer this question even without having the data and also just using economic reason, because even if you don't have the data in terms of like the beta 2 or covariance, exact covariance between X and Z, you can still figure out like, well, if I am given these two variables, then I would expect their relationship to be positive or negative because of this kind of mechanism. Okay, so the sign of the OVB is determined by multiplying the sign of omitted variables effect on Y by the sign of the correlation with X. Same sign mean upward bias, opposite signs means downward bias. In the next video, we'll visualize this bias so you can see exactly what upward and downward bias look like. But I hope this video was helpful, and I'll see you in the next one.